Hello everybody, welcome back to my video lecture. I am Dr. Muhammad Hayat Razvi. Now the topic we are discussing in this video is intermediate frequency receiver. The general CW receiver, CW radar receiver, which we have discussed in the previous class, previous video, was a simple super heterodyne receiver. Super heterodyning is nothing but using a mixer along with a local oscillator. In this video, if you observe, in this diagram, if you observe, the frequency F0 is transmitted. It will go, hit the target and come back to the same antenna. This system, this block diagram, has a single antenna which acts as transmitting antenna as well as receiving antenna. The signal which is fed to the antenna having a frequency of F0, if a part of the signal as the leakage signal is fed to mixer also. Mixer have two roles here. One is heterodyning the available two frequencies and detection. The received signal varies with the transmitted signal in two ways. One is in its amplitude, another one is its frequency. If the target is moving, the frequency will have Doppler effect, a Doppler shift, so the frequency is represented as F0 plus or minus Fd. Out of the available two frequencies to the mixer, this mixer will cancel out F0 and output of the mixer will be Fd. So this Fd, which is called as bit frequency, will be the operating frequency till the indicator. In this, because of low frequencies, because of low frequencies, there is a noise called flicker noise. That flicker noise will predominate the actual result, which should not happen. See, this simple form of CW radar receiver have a bandwidth which is very large, wide bandwidth. Now, bandwidth and sensitivity both are inversely proportional. Because the bandwidth of this system is very large, its sensitivity is very poor. That means that this radar cannot respond to a particular band of frequencies. So that is called as sensitivity. Okay, sensitivity as well as selectivity is also poor in this system. This system don't have any intermediate frequency. This is directly demodulated, and the Doppler effect, the Doppler shift is identified on which the circuit operates. As this does not have any intermediate frequency, this system is called as zero IF system. This system is called as zero IF system. Moving forward, because the Doppler shift normally will be of very low magnitude, this Doppler shift is of very low magnitude. When a circuit is operating at low frequencies, there is a noise called flicker noise, whose effect is the noise power produced by the flicker effect varies as 1 by f power alpha. This is power f power alpha, where alpha is approximately equal to 1. That means if the frequency is decreasing, the noise power will be increasing. So this system is greatly affected by the noise because of low operating frequency. That is the drawback of the system. And its sensitivity and selectivity both are poor because of this large bandwidth. To overcome such issues, we are going to have a system which is called as non-zero IF receiver. In this non-zero IF receiver, you can observe two separate antennas, one for transmitting, another one for receiving. The transmitting antenna is fed with the large power with frequency F0. The same frequency F0 is given to the mixer. The mixer is connected to a local oscillator which produces FIF, which is the intermediate frequency, and the heterodyne output of this mixer have three components. One is F0, another one is F0 plus FIF, another one F0 minus FIF. Out of all the frequencies, this sideband filter is something like a low pass filter which passes. It's a high pass filter, not low pass. It's a high pass filter which passes only the high frequency, which is F0 plus FIF. It will block or discard F0 and F0 minus FIF. The output frequency F0 plus FIF is heterodyned again with the received signal. We already know the signal F0, if transmitted, if the target is moving, that will have a Doppler shift, and the resulting frequency that in the echo will be F0 plus or minus FD. Now this plus F0 plus or minus FD will be heterodyned with F0 plus FIF. Out of these two signals, F0 is common, so this F0 will be cancelled by this F0. Rest of the two frequencies FIF plus or minus FD will be the output of this mixer. In the previous case, we have seen the operating frequency as FD. FD is normally of the order of kilo ohms or very low. The low frequency effects produces flicker effect, which is called as flicker noise. So the previous system suffers from flicker noise. That is the reason why we have intentionally inserted a medium or high frequency, which is FIF, which will not let the system suffer from the flicker noise, which was the earlier case. Now the system operates at a operating frequency of FIF plus or minus FD, which will be amplified by the IF amplifier and 2D detector, followed by the Doppler amplifier. After the 2D detector, the system will produce the Doppler frequency, and this Doppler frequency will be given to the indicator to show at what velocity the target is moving. So instead of the local oscillator, in the first case also, instead of the local oscillator, we are using the leakage signal from the transmitter as the local oscillator signal, which is an advantage. And these concepts are simply called as super heterodyne concepts and super heterodyne receivers. Okay, so by opting non-zero IF receiver, we have reduced the flicker noise in our system. Now let us compare this comparison between zero and non-zero IF receivers. Zero IF receiver is not sensitive because increased noise at lower intermediate frequency caused by the flicker effect. So zero IF receiver is not sensitive and it has large noise, whereas non-zero IF don't have these two issues. The reduction in sensitivity has a greater effect on the maximum efficiency of CW radar. Normally, any system's efficiency is depending upon its sensitivity. If the system is very sensitive, it will be responding to a very weak signal also, because there is a large noise effect over the system in the previous case, that is zero IF system. So it is sensitive, it is not sensitive, and one more reason is because of the large bandwidth of the zero IF system that is not sensitive. Here the bandwidth is very narrow and its sensitivity and selectivity both are very high. So the third point is the improvement in receiver sensitivity with non-zero IF receiver might be around 30 dB over the zero IF receiver. Over the previous case, this system works very efficiently over 30 dB. 30 dB is not a little figure. It is very good improvement over the previous system. So this is the comparison. I hope you understood this topic. If you have any doubts, you can leave your comments. Thank you.